Okay, this one is an important one to do because there's only a couple like it. So this is all about linear programming or using linear inequalities, which are what's labeled down here as constraints. We're using those to come up with something that we're trying to optimize, the maximum or minimum. There's this feasible region, the region that satisfies all these things. So for example, let's start with y is less than or equal to 18. This is the y-axis, right? So that's where y equals 18. So there's this whole area down here, all the way down to the y-axis, and below, and also to the left of 0. All of that could be a solution if that's the only constraint. That's the only thing constraining us, like a constrictor. Okay, anyways. But we also have this other constraint. X needs to be bigger than 6. So whatever x is needs to be greater than 6. And so that means to this direction. And then less than or equal to 14. So here's my 14 line. So now we have this area in here. That can be a solution. And at this point, I can kind of erase out here. So what the constraints are doing are slowly decreasing the size of our region that could be the answer. But that whole region right now can be the solution. All right, last piece is this one. But we can't graph that right now because it's not in slope-intercept form. You could, but that's not the way we've been graphing it. So your first step, just solve that for y. Subtract x from both sides, and get 2y greater than or equal to negative x plus 40. Divide by 2. Y is greater than or equal to negative 1/2 x plus 20. So we go to 20, negative 1/2, so down 1 over 2, down 1 over 2, down 1 over 2, down 1, 2, down 1, 2. And it says our answer needs to be greater than, that means above. So this is now the region that we're interested in. Not this down here. Didn't mean to erase that constraint. Whoops. Draw it back. Okay. And so we have points. The corners, or the vertices of this, represent maximums and minimums. That's where they occur. And you could try a whole bunch of points and you would find that to be true. So either the maximum or minimum could be at these points. So we're going to label these points. We've got 14, 15, 14, 18. We have 6, 18. And then this one is 6, 17. And that's where we get to our objective function. All right, the bell's going to ring on me, so I'm not going to be able to finish all this, but here's our objective. A equals 3x minus 2y. And what you do is you take your points, so like 6, 17, and you plug them in to the objective function. So 3 times 6, that's x, minus 2 times 17, that's y, equals what? 18, negative 16. Okay, so that's a small number. If we're trying to minimize, that could be the smallest number we have. If we're trying to maximize, we're looking for the biggest number. And so what you're going to do is you're saying there's an x value of 6 and a y value of 17 that will maybe give me the minimum value for this objective, like if you're trying to minimize your cost, or maximize if you're trying to maximize your profit. So there's that one. Pick back up with another video.